combine this. This is the things you have to solve. So how you do this? So this one you have to learn. So for example, now first I take f plus g. This is the operation, right? F plus g x, right? These are things you need to calculate, right? Okay. Oh, if you see these kind of things that you need to solve, so you can break this one. Let's use your fx plus gx. If someone asks, if any point that you make this kind of thing, you have to do f plus g times x. So you can divide it into this. There's no errors if you do this part. Right? You break these functions into this. So in here you don't know how to do this, but if you break it into like this two, then now you know how to do it, because now you know fx separately and gx separately. You can apply it. Fx means 1 times 1 plus x minus 2 plus gx means x minus 3. Now you can solve x plus 2 x minus 2 minus 3 plus 1 means minus 2. So this is the x plus g x. So what we are learning here, we are going to combine functions. So these two functions are combined, not only uh, adding operations. Let's see. You have to solve this one, x minus g x. So the procedure is same, but you can break it. This f minus g, then that means fx minus gx. You can divide, not divide, you can break or separate. Now these functions, you know, fx means x plus x minus 3, gx means x minus 3. You have a bracket here, the right have common answers. So I'll write root x minus 2 first, then minus positive x means minus x, minus times minus 3 means plus 3, plus 3 plus 1 means plus 4. This is the answer. Okay. This is the way you handle the problems that you have a combining function. So first one, you have to make this, then this one. After that, if you make this multiplication f dot g, this expression f dot gx, no different, no any different. You can follow the same rule. This one you can write fx times gx. X. To break into this, you know the procedure. You can break. Okay. You know the rule. There is no worries about. You can separate the functions as like this. Then x means 1 plus x 2 minus you can solve the bracket here x I will multiply by 1 1 I take this x times x is the answer. You can't solve or simplify that because of my example. So you have to simplify then you can. So if you see this kind of multiplication, then you know how to function. So you can do these things. There is no error. But to find out this, you can do. So we have this part. And the division over G. Same. Right? Can apply XC over here. Likewise, you can simplify the things to make this kind of conversion function. So x1 plus 2 gx means x minus 3. But here you have to careful little bit because now this is the function. So you have to mention this here inside these functions. You can see there is a square root, and you can see in the denominator you can see x minus 3 here. So you have to write here because in that you cannot apply x equal to 3 here as well as here. You consider this one. Always you have to apply what x is always what
greater than 0.
greater than not 0. Otherwise you can see here. You can say this x minus 2 always greater than 0, then x greater than 2. And because we have to consider this here also, we cannot apply minus or negative values inside this here. Therefore, to find out the domain of this new function. So these things now you already know. I will write some extra things. Actually, if you this one, so this is one function fx. So this is dx. So if you see these functions separately, so this is fx. The domain. What is the domain of fx? All the real numbers. No. Domain of fx is x is greater than 2. You have see in this function you can apply any values. No worries. Okay. But the new function, this new operation is for gx, so you have to consider this denominator part also. Then you have this hx should be equal to this provide become 0 and some number divided by 0 is not defined. That's the case. Now you know about the combining this kind of operation. You can solve it by this way. Then you have to keep in mind this one that is combined. Now after that You have a function of that is dx equals bracket. So someone asks to solve what is the answer of that. This so this is not the multiplication. We call this conversion. Right? This is not dot. Okay, there is a difference. Dot means multiplication. Of this is called conversion. Right? So if you see this kind of thing, that means the meaning of that is we can elaborate this like this way. So if after that on gx on gx, that means first you have to apply whatever the things on here variable into gx function g, right? After you got the answer for that, then you have to put it onto the function called f. That is the meaning. Here, if we elaborate this, see this inside the function f, you have gx. Gx means again you are putting x value into the function of g. That means, so for example, you need to calculate f dot g times 1 of x equal x. Okay, then you have to do this. What you are going to do, you first apply the point 1 onto g here, then root 1 is equal to 1. Now you know the answer. That g1 means 1. After that, you can find the f1. This is here. F1 means 1, 4, 4, 3. Okay, now you know the answer for that. Equal to minus 3. How to do this? First, you apply the point 1 dx, then the answer you apply to fx. So this is the process, right? But you can do it very easily. You solve this operation as like this way. You can bring the function to here. Dx means dx equal to root x root x. Now f on root x, that means fx means 1. You are putting root x to the place where x stands. Right? That means f root x. So you can write here root x, you can substitute root x for the x on fx function. Root x times 4. Now this is the answer for this. Right? You cannot solve. You can write this way. Root x means here 3 minus 4, that means x 0 to is the answer. Now, if someone asks the value for 1 here, you can simply apply 1 for this x. Answer is 3. So you can give the answer like this. If you simplify the operations using the functions, you can find the answer very quickly. Or otherwise, you can apply the point into percentage. Functions is into the gx. Then after that, you can apply the value for the fx. Then you can find the answer. Right? So, idea is that, right? So we call this to learn the part of the composition of. So you have to write the behavior of this notation. What is this notation? How we elaborate this function if it has this kind of notation. So right. That's it. Take some break. Let's take the same functions like what different. So someone asked earlier, now you find f is solved. Someone asked you e f. You know the here how to do this. Now this meaning of this is write down according to order of the functions stand on this equation. Now e f. You can see the difference. E fx means x minus 4. Then you can find here by applying this value for this function. Function is 3a. So we are able to apply x minus 4. This is the answer for this one. So earlier you obtained equation. So but get here this. Now see the difference. That is not equal, right? You can see the answers are different. So f gx like this way, g fx like this way. So you cannot uh, use the you cannot think these two are equal, right? These are different. Okay, that is extra. Let's take another example. You can get the idea. So let's take three functions. Fx equal to x, x equal 1. Gx equal take little different one over x. Then we take another function called h. this is the functions that you have. Now you have to find this the equation f of 1 f this is the operator that you have to find. Right? You have these three functions. Now you already solved all these two functions. Now you have three functions. Is there any different way to do this? So you can follow the similar way to solve this operation. That can you know the theorem. Plus, you can apply the way what you have got. So you write down. So separate these operations like f, then t on that. But inside t, you have another function called x. Table right. So if you have two functions, you only have this part. You have three functions. So what's the thing? First you apply the value or point to the edge, then you have some answer, then you apply it on the t, then you have answer, then you apply that answer into f, then you can find out or solve out this problem. So that's the meaning of this term. Right? So let's write f g x x x cube. Now you apply x cube to g. G means 1 over x. Then you can write, you apply x cube, g means 1 over x cube. Okay, now you simplify it like this. Now it's very easy. Now you have fx, you can apply this one over x onto this fx. Solve it and tell me the answer. To be able to obtain this, suppose you can write like this way: root 1 1. You can write down root 3. So you can write down like this. So now if someone asks the value for the f h at 1. You no need to apply 1 for x. Apply 1.1 to the x, then find out the value, and then apply from that value the g and find the value, and that value apply onto the f function h. Then you can find the answer. But if you simplify this earlier, okay, no need to worry about that. You can directly apply point 1 onto this function. Any power of the 1 equal to 1. So we have to find the value 16. Tell me the answer for it. So I need to find out the value, the point 16 for this operation. Can you give the for it? Yes, I will change the value. Take point. So the simplify. What is the answer? Please someone tell me the answer. No, you can simplify this. Yes, tell me.
108.
Yes. How to do this? Number 4 you can write down this way. 2 to the power 2. So, okay. 2 to the power 3 and 8. So you can find count to this answer. Right. So this part will help you to simplify, or yes, actually later sometimes you need to use this earlier one, like this combine function, that one for the conversion. Then if you come to this point, then you should know how to come to the final answer. So if you don't know these operations, how to handle, then you cannot simplify these things into the final answer. That is why I will add here, right? So these combining and conversions, that is sometimes useful to find out the final answers that you have you have made at the future, right? So now I will move to today's session and do the concept of the limits. So actually today I will not going to cover all the parts of the equation. I cannot do it like that. So we have to spend several lectures to understand to learn the limits, applying the different places, right? So today I will give you the concept, right? So don't try to find out the or memorize the all the things what I'm writing on the screen, right? But try to understand the concept, right? That's it. Because later you have to apply the concept in the different applications. Then you have to involve a little bit harder. Okay, you can put the title or link, right? This is the one of the major part in the calculus, right? So I will explain it a little bit. Uh, Actually, this is why we are learning the calculus, right? So I will explain. So you have some problem why we are learning the calculus, right? Actually, in the calculus you have two goals. If you know the calculus, you can achieve these two goals, right? So what are those? Let me say. First one is, so you have a function. Let me say. Then first goal is find the tangent to a curve at a point. Find the tangent to a curve at a point. So you can define point. Then, if you need to find the tangent to this curve at that point, can you do this? Right? So sometimes you may learn linear algebra, any algebra things in the mathematical uh, field. Can you do using that? We don't know actually what is instantaneous. So I will draw roughly. So this line, assume that this line is the tangent for this curve at this point. So this one is the first thing we can do if we know the calculus. Right? So achieving this one is a one goal. Second one, you have a then I have some sequence called a then I mark this area under this curve. Area under this curve. So boundaries are empty. So second goal is find the 2 points. So this one is a challenging problem, right? You cannot achieve or you answer for this using knowing the geometry or any other uh, field, right? Only calculus, knowing the calculus, you can achieve this goal, right? So that is why we are going to learn the calculus. Inside the calculus, we play a big role, right? Today, what we are going to learn. Right? So these are the goals. So in the future, you have to address these two, right? So at now you don't know, you don't have idea why we calculate the area under the curve or why we calculate the tangent to the curve at the position. You might not be any concern at this position, but if you make some application, calculate fraction, the application, then you can understand why we are going to learn these two, right? Okay. So these are the challenges, right? Let's I will discuss the first part, tangent part. Let's stop it. First, we have to understand some the concept behind it. Okay. Now I will explain why we are learning limits to find out or to achieve these two goals. So here I have curve. Let me show. I have a point called P at this location. Point P. Okay. So this is the problem, tangent problem. That means you need to find the tangent of at the point P, right? So this curve, I polish here, right? So that means you need to give or find the equation. Equation means like that the tangent is a straight line, so you have to give some greater than y equal something kind of thing. So you have to give a equation for the tangent line. Tangent line means uh, the tangent at the point P into this curve. The problem. Okay, now let's understand and check how to solve. So I will ask some questions. If you need to define a line, you need to define the line. You need to find the equation of the line. How to do this? You have to know first. With a single point, can you define a line? Yes or no? No. You should have then you should need 2 points to define a line. Otherwise, you cannot define a line. So let's take like this is this point. Let's say p2, then x1, y1, let's call p coordinates. Then I write x2, y2 development of coordination between 2 points. If you know this, then you can find the tangent to the gradient. If this is in the card, say what is the gradient? Means you can automate it. So you can find the gradient. How to do this? You can
Recording stopped. Recording in progress.
sorry, I lost the connection in the tablet. So can you hear me now? Yes. Verify.
Yes, sir.
Okay. So this is the given, yeah, saying right here mark 2 point called P and Q, then the coordination x1, y1, x2, y2. So if you need to find the gradient of this line, then how to do? You can take the difference of y and divide by take the difference of x, then you can find the gradient of this line. So this is the concept, right, of giving the gradient. So if you know the gradient, then you can give the equation for this line. How to do this? This one is known. Then you can write down like this: y minus y1 minus n times equal y times x minus x1. So this is the equation for this tangent line, right? So for that you should know the gradient. So gradient you can find using 2 points. Otherwise you cannot do that. Without 2 points you cannot find the gradient. Okay. So please excuse me for 1 minute. Yeah, agent call. for the trouble. Right? So now your problem is you need to find the equation for the tangent line at the point P to this curve, correct? So anyway, if you need to find the equation for the line, straight line, so this is the normal procedure you have to follow. For your knowledge, right? So in the calculus, right, so how to do? I mark another point on this curve. Called P. This P is not this extra. I will delete this part. On the curve, now you have 2 points. The problem is that your question is to find the equation for the tangent line at the point P. So assume that this is the exact tangent line. So that's how to draw it. This is the exact tangent line. Now I another point on the curve called Q, and I will draw a line using these 2 points. Now tell me, this new draw line, the orange color one, right? Approximation for this tangent line. Yeah, looking number 2 guys. Yeah, tangent line at the point P, right? ඒකට හොඳ approximation එකක්. It's a good approximation. Explaining these things graphically so you can understand very clearly. So I will mostly each part as easy to get concept multiply the equation. So please answer. Is this the good approximation for the tangent? Yes. Actually no. Answer is no. Why? You can clearly see the 2 lines are so different because if you find the gradient, if this new line is a good approximation for the tangent line is both gradient should be equivalent, should pass through the point P. This line is pass through the point P, doesn't matter, but the gradient is different. So two different lines, not a good approximation. So I will do this multiplication. I bring this defined Q point to then I will earlier part. So the approximation using tangent. Right? Okay, then now move on to this. If you increase little by little, let's take one more
ඉතින් මට මොකෑ
then going forward. Now it is better than the previous one, green color. Specifying your line defined using the P and Q, these 2 points.
නංගි බාත්රූම් එකේ මේක වහපන් බාත්රූම් එකේ සවර් එක වහපන්
Closer to the tangent line.
බාත්රූම් එකේ සවර් එක වහපන්
So how it is? You bring this Q point little by little closer to the point P. First one, you have it is a higher distance one. Then you bring the Q point here, here. If you bring this point into very near to the P point P, then you have a very good approximation line for the tangent line. So now here you are learning the concept. If you bring the Q point very near to this, very down, you can not very near, very near. Right? So what happens? Then and only you have a very good approximation for the tangent line using that 2 points, whatever you define the line. So this is the concept. So now you know the concept. So using the limits, you can find out the equation for tangent line. Why? We have to bring this Q point very near to the very closer to the P point. That's the task. So to do this, you should know the limits. Without knowing the limits, you cannot do it. Right? So that is why this is the first goal, and that is why we are going to learn limits. Right? So you can little bit write down here. So normally in a circle, you define 2 points, and if you mark line using these 2 points, right? We can call this line as can give the name called secant. So here you are drawing the secant line using P and Q. Right? So the thing is, if you bring the Q point very closer to the P point P, then and only you can give the best approximation for the tangent line. Alright, I will ask now a question. Can you bring the Q point onto P? That means P and Q are not different. Q on the P. Can you do it? මේ Q කියන point එක පාට P කියන point එක මතටම ගේන්න පුළුවන්. Yes or no?
no
No.
No. Why? I කියලා ප්‍රශ්නයක් කරගන්න. To define a line, at least that means we need to know 2 points. But if the Q and P are equal, that means we cannot define a line. That is why we cannot bring the Q onto the P. Right? But can you bring the point Q very near to the P? That means approach to the P.
And
Yes, that is not a problem. So we will not bring the Q onto the P. To do this, that is wrong. But we can Q approach the P. Where the approach is very near to the P. So we are talking under this condition. Right? If we are in this condition, we can define a line also. So we can do the or we can find the tangent to the curve at the point P under this condition. So limits help us to do this. Okay, I think now you understand it. So you can write down here as Q approaches P, sequence means the line. Sequence more closely approximate to the tangent. So what we are going to do here, we bring the Q point very near to the P using the limits. Then we finally comes to the good approximation to the exact tangent at point. That's it. So now you know the concept. Actually, really, or very near to the point P means that is we should call limits. So under limits, we are going to that. Now let's take example. I will delete this one. To understand the concept, I will example. So I have a function like this. I have point or P position so on. So my question is find the equation of tangent line to the curve. This is y equal x, right? The function at the point 1. So this is the problem. So how? I explained this one earlier. If you know the here they asked to find the equation for tangent line. Tangent line is the point P, point 1, the tangent. If that is the exact tangent at that point. So they asked the equation for this line. So I explained this one as extra part. If you need to express the equation of a line, you should know the gradient and should know a point that line passes through. If you know these two, you can write down the equation of a line. Right? Y minus y1 is equal to m times x minus x1. So this is the equation. Right? So for here, they ask again the equation. So for that, you should know the gradient of this line, tangent line, as well as a point. Point already know because point P means 1, 1, right? So this one is how to find the gradient of this line. You know these two, you can write down the expression for the line. So what we are going to do here, so you cannot find the exact tangent line, but you can give the best approximation for the tangent line. So if you define the Q point at like this place, then you can start to give some expression for the approximation for the tangent line. Then using the limits, you can bring this Q point very, very, very near to the Q point. After that, you can express or you can find out the gradient of that line. Then using that gradient, we can express a equation for the tangent line. That's the thing you have to do. So let's handle this first. So I will write. So this one m secant. That means first I draw a line in green color here between P and Q, right? Okay. So I need to know the gradient of this line. How to do? You know the function y equal x square. So if you need to find the gradient, you should know. If you know the coordination of these 2 points, you know how to do it. Because I explained it a while ago. y2 minus y1 over x2 minus x1 interpret the gradient of the line. Okay. x1 y1 you already know. Right? Can you tell me the x2 and y2 for this cube point? As a variable you can explain. Can someone tell me? This what? Sorry, I couldn't hear you well. Can you tell me again? I didn't get you well, right? Anyhow, please take a look. If you explain the same thing what I am writing here. If you define x as it is x, then you can define y as x squared, because y equal x squared. So this is the 2 points of this q. Q is movable or variable point. So I will write the coordination to the q as like this. For example, if you need to know the coordination at 2, then you can apply 2 here. You can apply 2 for here. 2, that means 2, 4. Like that, you can find the coordination. Okay. If you know the function y equal x squared, you can define the coordination to the q. Right? Now you can apply, or you can find the gradient of the secant line. Okay. First you can substitute y2. y2 means here x squared. y1 means 1, 2. x2 means x. x1 means 1. Right? This is the gradient of the secant line. Right? Can you understand up to this? Now, this is not a new thing. You write down the, you find out the gradient of the secant line. How to find out the gradient? If you know the points of these two, that is coordination, x and y values of that points, you can simply find the gradient. That's the things, very O-level mathematics I used here. Then when you come to this point, so gradient is like this way. You can say something more, right? Right here, numerator, you can see it has some factors. You can solve it a little bit, simplify it, right? X squared minus 1 means you can write down this one as x minus 1, x plus 1. Now you can see you can simplify this one a little bit more, but you have to be careful. Why? You can take out these two from the equation. Is it okay? Actually, yes. Why? Because we are not bring the point Q onto P. We give approach to P. Okay. At the P, the value of the x is 1. At the point P, the value of the x is 1. Right? So if you apply 1 here, then you have this kind of 0 divided by 0. You cannot cut this 0 to here and answer 4x plus 1. This is wrong. Okay. But we cannot bring the Q point onto P. So That means we never bring the Q onto P. So at that assumption, this one and this one will not go to the 0. Right? Will not go to 0. Under that assumption, we can cut or we can simplify these two and write down the answer as x plus 1. So this is the gradient of secant. Right? This is the gradient of the secant. Now you know the gradient of the secant. Right? Now you can write down the equation for the tangent line. Now you know the gradient. Now it is very easy. Now the thing is, m secant is a best approximation for the m tangent line. Right? Why? We bring the q really close to the p. Okay. That is why we simplify this part and obtain the tangent of the secant like this way, plus 1. Right? Okay, now we have a good approximation for the tangent. We assume this is the best one. Okay, now we have a gradient of the tangent. Right? Okay, now we can express the equation. How to do this? Y minus, I will use this y minus y1. Y1 means 1. M, we can apply M as x plus 1. Then x minus x1. 1 means again 1. Here x, here y. Okay, you can simplify this. You can simplify this, right? As like this way, you can write down the equation for the tangent. So you have to do little bit more, right? This is not the final answer for the problem. I will again delete little bit because okay, we have to do something more, right? But I explain how to give the answer. If you know the gradient, you can write down the equation for the tangent line. But here you can see m secant is x plus 1. So this one like that. It is not a constant, no? Because it is vary with the x, right? So still we did not bring the point q very near to the p. Right? So we have to use the limits. Now I will try to give you the concept of the limits. Right? So I will delete little portion of the screen. Let's take another color. Okay, now you have 1 second equal to x plus 1. Now the problem is what happened to m secant when as the point Q become to very near to P, or here if we are calling the X, then this value very near to the value of 1. So for example here if you define number 2 here is at this point 2, 4. You need to bring that value very near to 1. Right? So let's how to do this. So let's take like this way. You can start from the point 2. Sorry, here 2 is the point. Is x value, right? So you can apply numbers here. 2, then 1.5, then 1.3, then 1.1, right? Then 1.0, 1.000, so let's apply this and see what happens. If we apply point 2 here, then what happens to the secant? Gradient of the secant. You can apply number 2 here. Then it is equal to number 3. Gradient is 3 because at the point x equal to q is there. So gradient is 3. Yes, it's okay. Right? Then if you apply 1.5, then gradient is 2.5. Little bit smaller than the previous one. Yes, now it is become to the exact tangent line direction. Then you can apply 1.3 here. Then gradient is 2.3. Yes, is there. Like that way. You can apply 1.1. Then gradient is 2.1. Very nice. Right. Right. Then you can apply 1.01. Then gradient is 2.0. If you apply here 1.0001, then gradient is 2.0001. If you apply here 1.000000, then the gradient should be 2.000001. Now you can see the trend on these answers. The answer is going to converge to the point, to the value. No? Answer is going to converge starting from 3. When you come to very closer to the point P, the x value is very closer to the 1. X value is very closer to the 1. Then you can see the gradient of the secant going to where? Number 2. Right? You can see this. Right? So that the meaning of that is gradient of the secant is equal to 2 when you bring the point Q very closer to the P. So here we are doing the limits, right? We bring the Q point very near to the P, but manually, right? Without knowing the mathematical operations of the limits, we are doing this manually and see what happened to the answer. If you see this. That means you can assume when you bring the point P, or when you bring the x value of the Q, that is second point, is very closer to the first point, then you can see this gradient is converged to the x value called 2. Right? So using the limits, we are going to find out this, right? But in manually, for this example, we can see it, right? So now you can write down like this: this gradient of the secant is equal to when you bring the point P very closer to the Q, right? That means we approach Q, m secant is equal to the 2. The term is like that. We approach to the Q, m secant is equal to the 2, right? Now you know the gradient of secant, and you bring the you can change, you have to change it. You approach to Q, right? Not we approach to Q. You bring the Q very closer to the P, then it is a good or best approximation for the tangent line. Now you know the gradient of the secant line, but that secant line is a good approximation for the tangent line. Then you can write m tangent is equal to 2. Now you are end of the questions. You need to write expression for the tangent line. So now you can write down it. How to write down means y minus y1 is equal to the n tangent x minus x1. You can take the points y minus 1 equal to the 2 times tangent is 2 x minus 1. So you can solve it out. Y equal 2x minus 2 minus 1, you bring it to the same, plus 1, then minus 1. This is the equation for the tangent line which you draw to this curve called y equal x squared at the point P. Right? So this is the equation for the tangent line. So here you can see this. If we apply, we can find out the points at x equals 0, y equals minus 1. So it is going to be this point. Okay. So this is the concept, right? I think, I hope you might understand this, right? Only thing is the concept. So you have a major challenge to find out the tangent line to the curve at a point. So you know when you define another point, and when you bring that point really near to the point P, then you have a good approximation to the that line into the tangent line. So how to do this? You need to apply the limits to bring the point Q very near to the P. So in here we did it little bit manually to understand the happening inside, right? Later we use different ways, right, to apply the limits to bring this Q point onto the very big P. Okay. Let's take another example. Not another example. Let's talk the next challenge. So first challenge is to find out the tangent line of the curve at a point. Second one. So first one is tangent problem. Second one is area problem. Area problem. So this is a new again concept you have to understand. What we are going to do with the limits. So in this challenge also, if we don't know the limits, we cannot achieve the goal. So what I explained at the beginning, so if you need to find out the area under this curve between these two boundaries, right? Using graphically, can you do this? So if you draw this kind of rectangle, right? This kind of rectangle, this red color one, and you can find out the area of this rectangle, right? You know this length, you can find this height, then you can express the value for area. But is it a good approximation for the area that you expect? No, right? We cannot find the area on this lasers that I'm highlighting. Is this part. Then what I am doing here, same curve, same boundary. Then I will divide it into several rectangles. Now I can find the area of these all rectangles, and we can add area. You need to be like that, a1 plus a2 plus a3 plus a4 like that, plus a6. Right? This is the total area covering from this part. Is this one is a good approximation for this area under this curve? What we are expected to find?
Yes, sir.
answer is given, right? With respect to the previous case, is the best approximation, but is not the good or best approximation for the answer. Why? Still, we have missed several areas, right? But this one is uh, good than the previous one. Okay, now you have some point. Right? If you divide the total area into very small rectangle, very small, and when you add all the values of this area of the little or small rectangles together, then you have a good approximation for the total area under this curve within these two boundaries. So to do this, to, the, to know the geometry, right? So you can draw the rectangles and you can try out to find the area. But if you know the calculus, it's very simple. Right? You can do it fast if you know the calculus. Right? So this area problem is also a challenge, but we can deal that problem using this way. You know the way. Okay, let's try to understand a little bit more. Now I will come to the main title, right? Limits. That is the things what we are going to learn. But before come to this, I explain why we are going to learn the limits. Right? Now we have a two challenge to achieve or to achieve that challenge or goals. We should know the limits. That is why we are going to understand or learn the limits. So if we spread or elaborate these limits, you can write down this way. You can elaborate this term limits like this way. Let's write what does the function do as the variable approach a given value. So in the limits, this is the things what we are going to do. What does the functions do as the variable approach a given value? For example, earlier case, we bring the x value very near to the 1. Right? So then we can find the gradient of the secant, that gradient value very closer to the exact tangent line of the curve at that point. So we can find out the equation. So in the limits, what we are going to do, so what does the functions do? We are find what does the function do as the variable approach the given value, right? So this is the limits what we are going to learn. For example, let's take earlier one, fx equal x square into x square. Then the problem is what happened to function as x approach 2. Let's try to understand this. X approach to 2. Right. I'm going to write down the x and fx. So we don't know here. This is the things what we need to find. Right? X approach to, not substitute, right? Approach to. So we can bring our value or variable from right end to the point and left end to the point. Okay, okay. Let's do it. What are the nearest values in the both end? We can start say 2.3, then 2.1, here 2.001, very close. You can find the value. Right? Then for the symmetric, I will take 1.999 here, 1.9, 1.7. Now it has a symmetry. Okay, can you find the answers for function is fx equal x square? Starting from here, you can tell me the values. What is the 1.7 squared? Can you tell me?
2.89.
2.89. Then 1.9 squared?
3.61.
3.61. Then 1.999 squared? Using the 3 decimal places, can you give me?
3.996.
3.996. Here, 2.001.
4.004.
4.004. 2.1.
4.41.
4.41. Here, 2.3.
5.29.
Okay, thank you. Right. Okay, now we have the values, right? We did not substitute the 2 here because we cannot do that, right? In the limit, we are doing the limits now. So we cannot substitute 2 under the function. That things we cannot do. But we cannot bring the values very, very near to the point and see what happens. So that is the things we are doing here. So we bring that variable from right end and the left end. So you can see the values. So here, this value 4.004 and this one 3.996. You can see it now, right? So you by looking this value and this value, you can write down what will happen when the x value is very near to the 2. So you can write it here. So it is going to number 4. See, this one is reached 4 from left-handed, and this one decreasing up to the 4. So reaching the same value from left, right hand end and the left handed. So we can write, okay, we can write this notation of the limit right? X going to 2 x squared, right? Limit of x squared when x going to 2 is equal to what? Equal to what? For this case, 4. You can see it using this diagram. Right? X and x squared කියන්නේ අපේ function එක. මේ function එකේ x කියන variable එක අපි පුළුවන් තරම් number 2 value 2 එක ළඟට ආසන්න කරනකොට අපිට පේනවා එයාව convert වෙනවා කියලා එක point එකකට ඒක graphically අපි දැක්කා මෙතන number 4 විදිහට අපිට ලියන්න එතකොට ඒක නිසා තමයි volume right? So this is an example, right? You can see it, right? When the limit of x squared, limit of x squared when x is going to approach to 2, right? That this the answer is 4. So in general, you can write in general, right? You can write down this limit of fx, limit of fx when x approach to a, right? That is the constant value a. That value is going to L. L is a scale, some point or constant, right? So this is the general term, right? We can notate this at this point, at point A, this function going to this value called L. Right? So we represent that part as like this, limit of fx when x approach to A is equal to L. That's the general notation. So you have to familiar with this notation. Right? Okay. You can write down this. Right? So I am writing like these things to understand what is happening inside, right? So keep it in mind, we will not going to apply a number from here to here and see the limits, and this is not the way to find the answer for this, right? I write or I wrote this one here to understand what is happening inside, right? So later we have to prove some points of the limits, then we can directly apply these points to find out the limits of the function. So later we have to do like this way. Okay, so I hope you can write down those. Okay, I will explain that another example. Now our function is x minus 1 divided by x squared minus 1 is the function. I need to find out the value of this function, then x approach to 1. So this is the problem. Right? Graphically you have to do that. Right? Let's take 3 from left hand end. This is the point, but we have to find the value. Then 3 points from the right hand end. Okay, 1. I will start from point 1, then point 0.9, point 99, point 99, say 1, so can you tell me the values for you have a calculator, so you can find out the values. For scientific calculator, you can first enter the equation. After that, you can simply apply or simply enter the values, then it will give you the answers directly. At point 9, can someone tell
0.526.
0.526?
526.
Point. Did someone verify this value, or did you have a different different answers than this one?
Same answer.
Right, same. It's okay. Then for this case, 0.99. Others, please find these values also. Can I ask, please?
0.5025.
0.5025.
25.
Let's that 5 here. 0.50.
0.50025.
0.50025. I will write 3. Okay, good. Then descent, right hand. Sorry. For this one, 1.01. 1.1. 0.476. Okay. Now you can see the trend. So in the right hand, this become to some value 5.52, 0.50, 0.5003. In the right hand, you can see 0.47, 0.49, 0.4999, like that. So you can assume the value when what is the value going to be converted. So it should be 0.5. This comes the value of 0.5. So this function, right, the limit of this function when x approach to 1 is going to 0.5. Right? By looking this table, you can actually assume, right? So the similar example, right? Previous one, like that. You are doing it manually and see this function is conversion to 1 point. So from the right end and the left end, it becomes to converge into one value, not a different value, right? So now you have some problem. So let's see. So I will take another 5 minutes. So you have some function like this. I will draw a function graphically. So I will write down the value. This is -1. This is +1. Okay? At the point 2. So this is the function called you can call it fx. Right? So I am asking you this limit of fx at x approach to 2. What is the value? By looking the graph, can you explain? Or you have a trouble to do that? Then explain. මෙහෙම දැන් මේ ෆන්ක්ෂන් එකේ මේ අදලා තියෙන graphical interpretation එකේ මේ ෆන්ක්ෂන් එකේ x කියන එක number 2 වලට approach වෙනකොට සීමා වෙනකොට මේ x වලට එකට අගයක් දෙන්න පුළුවන්. එහෙම බැරි නම් ඒකට හේතුවක්. Okay, let's find out. To give this value, you have to come from the right end and the left end. That is the way you can do the corrections problems little while ago. So let's write at the right side. I will write like this way: limit where x approach to 2 from the right end. I will write the positive mark to indicate now I am coming from the right end. Right? Can you give me an answer? When you coming from the right end, right? What happened to the limit of fx when it reached number 2? Can you give me an answer? මේ fx කියන එක කෙනා right මේ ඉඳන් එනවනම් මේ fx ට values තියෙනවා. එතන ඉන්නකොට තව value එකක්. එතන තියෙනකොට value එකක්. තව එකක්. කොහොම number 2 කියන එකට partition එකේ number state එකේ number 2 කියන එක තැනට ලං වෙනකොටම මේ fx ට ගන්න පුළුවන් value එක මොකක්ද කියලා මම අහන්නේ right end එකේ ඉඳන් එනවා. මොකක්ද value? What is the value? By looking this graph, there are so many values. You can tell me one. What is the value? 1. Extremely, you can say positive 1. Moment. Okay. Then I will ask another one. Left side. Limit of fx when x approach to 2 from the left hand. I mark the negative sign. Now tell me what is the value. Negative and left hand එකේ ඉඳන් number 2 වලට එනකොට මේ fx ට ගන්න පුළුවන් value එක මොකක් කියලාද හිතන්න. කොකටද තැනකටද conversion. මොකක්ද value එක? Sorry? minus 1. Yes, you're correct. Then one ප්‍රශ්නය. Now you have a trouble. Not like the earlier case. The earlier case, you are looking at the point, you come from the right end, you come from the left end, and both, when you come to both ends, the value for that point is going to only single value, right? That is why you write it as like this way: x, when x approach to a, it is going to l. But here, can you write like this way? No. Why? It is totally different. When you come from the right end, the value is plus 1. When you come to the left end, the value is minus 1. So you cannot write now the limit is like this because they are reaching into two different values when you come from the right hand and the left hand. So what happened here? Actually, for this case, for this function, right? For this function, limit is does not exist, right? Now you have a point to limit exists. There is a things to happen. Now you know this how to write it. I will write down it here. This is not for a limit to exist at let's say point A, right? You must have what limit of fx when you come to that value from the left hand side should be equal to limit of fx when you come from the right hand side to that value, right? එතකොට මේ limit එක පවතින්න නම් ඔයා A කියන point එකට right hand side එකෙන් ආවොත් හරි left hand එකෙන් right එකෙන් ආවොත් හරි ඒ දෙන්නම conversion එක value එකට. එහෙනම් මේ function එකට A කියන point එකේදී limit එකක් තියෙනවා. හැබැයි එහෙම වෙන්නේ නැත්නම් මේ වගේ case එකක් ඒ function එකේ ඒ point එකට limit එකක් පවතින්නේ නැහැ. it's not exist කියලා කිව්වේ ඒකයි. මේක තේරුණාද? එහෙනම් හරි point එකට when you have a limit at a point then you should have the limit of fx, right? When x approaches to a minus should be equal to the limit of fx when x approaches to a positive. Right? මේ දෙන්න සමානව විතරයි මේ කියන point එකේ limit එකක් ගන්න. ඒතකොට මේ වගේ අවස්ථාවක මේ 2 කියන point එකේදී අපිට limit එකක් කතා කරන්න බෑ. ඒතකොට මේ වගේ ප්‍රශ්නයක් අපිට solve කරන්න බෑ. right? ඒක මතක තියාගන්න. හැබැයි right, tell me again this one. Let's assume the point 3 x equal 3. Tell me, is there any? Tell me, can you find the limit at the point 3 or not? මේ 3 කියන point එකේදී limit එකක් ඔයගලන්ට හොයන්න පුළුවන්ද බැරිද? By looking this graph, you can tell. පුළුවන්. Yes, you can. Right? You can come from the right hand and then you can come from the left hand and you can see when you come from these both ends is come to one point, right? But in here at the point 2 according to this function you cannot do this, right? So the idea is that limit is exist or not, you can define, that means you can find the limits at the same function at different point, but some point it might have a limit, but some point it might not have limits. That is does not exist. So you have to understand it. So anyway, if someone asks to find the limit at a point, so you must, if you need to give an answer, you must have these things happen. Otherwise, you cannot express the limit for that point. Okay. Right. So time is already 20 minutes past, but it's a lunch time, that the extra time. So anyhow, today now I will going to close the session. And tell me, do you have any extra time in your timetable for today or tomorrow or Friday? Okay. Who is the batch ref of your group?
Yes, sir.
Right. Can you send me a time slot that you are convenient? Time slot. It is okay, 1 hour or 2 hours, right? And if I manage to approach that time slot, then I can conduct some extra class, because we have missed 2 or 3 classes, right? So please send me an email, right? Indicating the time slot that you are convenient to handle the extra class, right?
Okay, sir.
Right. Okay. Thank you. Message that you have any message. So, ප්‍රශ්නේ හරියට තේරුම් මොන තේරුණත් මේකයි මම අද කලේ concept, right? ඔයගලන්ට ඒක තේරුම් ගන්න මේ තියෙන concept මම ඔයගලන්ට deliver කරන්න concept. ඒ නැතුව අර ප්‍රශ්නයකට උත්තරයක් හොයන විදිහ නෙමෙයි මේ කරන්නේ. එතකොට මේ concept එක ඔලුවට දාලා ඊට පස්සේ ප්‍රශ්න වලට උත්තර හොයන්න ඔයගලන්ට ඇත්තටම තනියම උනත් කරන්න. right? එතකොට ප්‍රැක්ටිකලි දා ටේබල් ගහලා ආන්සර්ස් අර සබ් එක ඒවා ආදේශ කර කර පෙන්නන්නේ ඔයගොල්ලන්ට මේ concept එක ඔලුවට යන්න ඕනේ ඉඳ විතරමයි. මේක නෙමෙයි මේ limits කියලා ඇත්තටම කරන්නේ. මේ concept එක ඔලුවට දාගන්න. concept එක ඔලුවට දාගත්ත පස්සේ limits කියන එක නැති. right? Okay. Thank you very much. Then I will close the session. And if we have a chance, let's meet again before the next Wednesday, right? Okay, thank you very much.
Thank you, sir.
Recording stopped.